process scheduling is concerned, okay, as far as the process scheduling is concerned, each and every process having own meaning. So we have the not a one process, two process. We have the n number of process, and all the process are ready to execute for its execution. So it's a better idea to have some algorithm by which we can process all the algorithms with step by step and with help of the some algorithmic step. See, we have seen the first come first serve algorithm in the process scheduling round robin, and we have also discussed the priority scheduling algorithm, and there are lots of algorithm we have discussed lot at that time. Now it's time to discuss about the disk schedulings. Now, what do you mean by the disk scheduling? As we know, the disk scheduling is a scheduling algorithm which is used to manage the disk. Because in our hard drive or in our hard disks, what we have into the our storage media, that is followed by the some disk. Like example, in the earlier days, we have the floppy disk, as we are familiar with this term. But now this is not era belong to the floppy disk. So at the time, the at the earlier days, we have the floppy disk, which was a very essential storage media. Now we have the now hard disks. Now we have the external hard disks, we have the internal hard disks. So there are lots of the things we have the into the form of the storage purpose. Now we have in our pocket, that is also known as the pen drives. So into the pen drive, we can store the information into the form of the integrated circuit or chips as well. But when the disk is concerned, like example of the hard drive or hard disk, that is HDD. So at the time, how disk will read the data and what is the purpose of disk, that is the most necessary part. Because in our hard disk there is no single disk, there are lots of the number of disks are available. So which disk plate should be read the data first, that is necessary part. And in the fundamental part of the our syllabus or fundamental part of the computer system as well, we have already noted down that the disk is just having by the own meaning, as well as it has own different parts, and those are track sectors, and each and every track has own sector. So disk is divided into the different components or different parts, and those are recognized by the sector and track. And we have the n number of disks, so we can say disk 1, disk 2, up to the n disk. So data reading into the from the hard disk and data writing onto the hard disk is a most important part by the operating system. So operating system also determine that which disk should be readable at that time and which disk is not readable at that time. So that is also determined by the some part, and that is also known as the component of the hard drive disk, that is known as the uh, arm head. So arm head determining that just how to read the data, or which part of the disk or which part of the track of disk should be readable. Now come to the point, as we know into the earlier days when we are listening the songs from the gramophone. So at that time, what happened at that time? There is a disc of plate is available, and there is some pointer is just we need to put on the disc, and on which some information will be readable by the disc, and that is followed by the pin, and that is also known as the arm head. So we will see
Excuse me,
this
sir.
through yes, this yes, hello, yes.
So your slide is not changing actually. So it's
Yeah,
on the.
I have not changed my slide. This is I'm just giving the introduction right now. Okay.
Okay, sir. Okay, sir.
Okay. So this is just introduction. I'm just giving because this is the points I'm discussing over here only, which are related to the fundamental parts. Now, whenever look to the my next slide, then you will see the image and you will feel okay. So you spoke the things related to the disk, that is visible to here. So that's why
Okay.
I'm coming on to the my slide. Don't worry, don't worry. Okay.
Yes.
So this is a point we have already noted down in our mind. Now, as we know, the gramophone. Okay, gramophone. What is disc? Now we have the disc, that is a black color disc, and which is just having the layer of the magnetic tapes on the data to be stored. So when the through the gramophone pin or head, we read the data. So we can listen the beautiful song that is through the gramophone. So this is the basic idea we have seen through the previous days, earlier days. So same thing we have open here. So now I'm just make changing the my PPT into the full screen mode, and then you will see in proper way. So now I have just maximize my screen in the full screen mode, then it will be visible. Yes. Now I'm just coming to the my first slide. That is the second storage. Now, what is mean by the primary storage? Primary storage is a memory on which the data is to be stored for the temporary purpose when the light goes or data to be flushed out without any doubt. So this is known as a primary memory. So RAM is the best example at the time. Now we have the RAM in our computer system. It's the best example for the primary memory. So secondary memory devices are those devices whose memory is non-volatile. So as we know, the RAM is a volatile memory. So meaning the stored data will be intact when even if the system is turned off. And as I am speaking through the primary memory. So primary memory is a memory when that power goes off. So data will be lost without any doubt. So that's why it is known as a volatile memory. So here we have the few things we need to keep in mind about the secondary memory. So those are secondary memory are also known as the auxiliary storage devices. Okay, so please keep in mind into the examination purpose whenever I can ask this question into the different way. So what is mean by the auxiliary device or auxiliary storage? Then you have to write the about the secondary storage. Now, secondary storage is very less expensive when compared to the primary memory like RAM. Very truly speaking, if you're trying to look for the RAM, what happened? RAM could be around 2,000 rupees or 4,000 rupees, depend on the your what is the size you want. So 8 GB for 8 GB or 16 GB RAM, you have to pay approx 3 to 4,000 or maybe the 5,000, depend on the company. But you are looking for the hard disks around the 1 terabyte. In today's era, I'm speaking, you're looking the hard disk around 1 terabyte. So what happened at the time? Within the 5,000 rupees, you can purchase, you can buy 1 terabyte hard disk, and which is a much space or more spacious size compared to the RAM. So this is a good idea. We can say that it is a less expensive. Okay. So the speed of the secondary storage or secondary memory, I can say, is also lesser than the primary storage. This is a true fact we need to keep in mind, because primary memory is directly connected with the CPU, and CPU can directly communicate to the RAM, and that is the main memory as well. So when the data is required to access its address, that is also known as the logical address, so CPU can communicate directly without any. That's why we can say the accessibility of the data or data fetching capability through the CPU is high compared to the secondary memory. Okay, this part we also discuss into the paging concept. Now, the data which is less frequently accessed is kept into the secondary storage. Definitely, when we need to store the data permanently, or we are looking for the data for the future purpose. So definitely, we use the secondary memory. So we can use a few example of the magnet tapes, removable thumbs drives. Also, these are the best example for the secondary storage. Okay, so this is just idea about the secondary storage I have spoken over here. So any doubt over here? What is mean by the secondary storage? Any doubt, students? Yes, student, if you have any doubt over here, then you can ask me.
No, sir.
Okay. Basically, this is
हेलो.
fundamental part. Yes, it is fundamental part I'm speaking. Yes, anyone
हाँ, दो
who wants?
सेकंड के लिए वाईफाई चला गया था, मतलब इंटरनेट चला गया था, वाईफाई नहीं.
तो प्रॉब्लम सुन नहीं पाई थी पूरी बात?
पता नहीं, बीच में होता है ऐसे कभी कभी.
ओके, ठीक है, मैं एक सिंपल समरी में बता दूं कि
हाँ जी भाई.
सेकेंडरी स्टोरेज वो डिवाइसेस होती हैं जिनमें हम डेटा परमानेंटली स्टोर करते हैं, और रैम हमारी प्राइमरी मेमोरी है। जो प्राइमरी मेमोरी की बात करेंगे तो जो डेटा उसमें स्टोर होगा, वो जैसे लाइट जाएगी तो क्या होगा, लाइट जाती है डेटा उसमें चला जाता है जो उसमें स्टोर होता है, इसलिए वो क्या कहलाती है, आपकी वोलेटाइल मेमोरी कहलाती है। ठीक है। और नॉन वोलेटाइल मेमोरी क्या होती है आपकी, इसमें डेटा आपका परमानेंट प्लीज म्यूट होता है।
कि मैं
Yes. Who want to speak? Please speak. Yes. So in the primary, what happen when the data is to be lost when the power goes off. So data is not permanently stored into the primary memory. So whenever we need to store data permanently, so secondary storage, secondary device is the best example. In the earlier days, we had the example. Those are the magnetics, magnetap. Magnetics or magnetapes and the removal thumb drives are the best example at the time. But in the nowadays, we have the hard disks drive. Okay, and we have the pen drive also best example, but in the pen drive we can store the data into the form of only the in the form of only the chip and integrated circuit, not into the form of the disk. So this is the point we need to keep in mind, but this is also secondary storage. Okay, why secondary storage is also known as the pen drive? Because whenever we need to boot our system, or whenever we need to access some information through the pen drive, we can access. But whenever it is necessary to boot up your system, then primary memory is required, that is a RAM. So without the RAM your system can't be boot, and but without the hard disk or without the pen drive your system easily boot without the hard disk or without the pen drive your system will be easily bootable, but without the RAM it can't be. So this is the point we need to keep in mind. Okay, now shall I move ahead? If you don't have any doubt over here, then you can say, shall I move ahead?
Yes, sir.
Okay. So now here I'm focusing the structure of the magnetic disk. Why magnetic disk? Because a disk which is followed by the some magnetic layer. When the information is to be stored into the form of the magnetic layer form, and since the fundamental part of the there's a book that is written by the Ramanujan. So Ramanujan is the name of the author, in which the diagram was mostly famous, and that is the structure of the disk. The what happened at that time, the disk is coated by the some magnetic layer. Please remember the words, disk is coated by the magnetic layer, and information to be stored into the magnetic disk followed by the some magnetic layer. So that's why the name given, that is a magnetic disk. And same things we have the magnetic tape. Like example of the our in the earlier days or few years ago, we have seen the BCR, and that is video cassette player and video cassette recorder, BCP and BCR, in which we have what we have the audio and video cassette. So the tape is available, and tape is coated by the magnetic layer, so that's why that color is just like the dark brown. So because it is just coated by the magnetic layer, so when the information are required to be stored, so on the basis of the magnetic tape part, the information to be stored permanently, and depend on the some capability, it is a removable disk or it is erasable or no, it is a programmable disk or a programmable tape or a programmable magnetic disk. So depend on the category. Okay, so but general way we can say it is coated by the magnetic layer, so it is known as the magnetic disk or magnetic tape. But when the disk and tape is concerned, in the BCR and BCP and audio cassette, you can familiar with this is the magnetic tape. But when talking about the magnetic disk, so there is disk. So in the disk, basically what happened in the disk, there are a few things are available. So those are known as the some track and some sector. So disk basically is followed by the circular way. So in the circular way, we have a disk. Each disk is divided by the different parts. Those are recognized by the track and the sector. So as the diagram, you can see into our hard disks we have into the form of the various number of disk. Since we have the 1 TB hard disk, we have the 512 GB hard disk, or we have the 256 hard disk. So we don't have a one disk. We have the various number of the layer of the disk, and each and every disk contained by the different sector, different tracks. So please keep in mind that our hard disk look like this one. So in the modern era, definitely we can say that in the modern computer, the most of the secondary storage is in the form of the magnetic disk. Hence, knowing the structure of the magnetic disk, it is necessary to understand how the data in the disk is accessed by the computer. Please keep in mind, this is the most important diagram for the understanding the disk functionality. So our disk is divided by the some track. Just like example of the when you are looking for the ground where you want to take a run of 500 meter or 5000 meter, what happened, there are some tracks are available. Okay, in the Olympic games or any kind of the games, you will feel this kind of situation when on the ground we have the lots of the track, and each and every track is divided into the different parts, and those are known as the sector. Please keep in mind, you can see the sector S, that is the little bit sky blue or dark blue color we have, and the track is defined by the different parts. So track and sector having the different meaning. Please keep in mind, disk is divided by the sector, and sector is, disk is divided by the track, and track is having own representation part, or we can say the track also divided by the some part that is known as the sector. So T is our track and S is our sector. Since all these track of the disk are associated by each other and followed by the cylindrical, so that is naming given, that is C. So what we have the plate, and that is known as the plater. Okay, so this spindle is basically is the connected to the all disk. So we can put all the disk into the form of the plate into a sequential manner. So through the spindle, through the, we can say through the rod, you can say, or through the basically it is a core part of accessibility of the disk. So when the spindle is rotated, okay, disk is never rotated. When the spindle is rotated, so what happened? Arm assembly or assembly part is a fixed part, and through the read and write head, information is to be read by the particular track or particular sector. But keep in mind, disk will not move, spindle will move, and which is just having the number of disk, and when the disk is moved, the automatically read and write head will read the data. So please keep in mind, arm assembly will not move, only the spindle will move. Okay, so this is the point you need to keep in mind. This is just idea about the magnetic disk. Okay, so before posting the this notes, most probably I am remembering the exact diagram of the hard disk, so I will share the actual diagram of the hard disk with this notes. So you will feel your actual spindle, and you will see the plater as well, but you can't see the track, you can't see the sector, because it is a internal part of the disk that is readable by only the read write head only. You are not able to see the track and sector. You can see only the spindle part, you can see the arm, that is also known as the read write head, and you can see also the plate, but you can't see the track and sector. Okay, this is a point you need to keep in mind. So magnetic disk structure is look like this one. So what happened into the secondary storage, we are familiar with this term. So in this term we need to follow all the things in proper way. So magnetic disk is most important part. Okay, so why magnetic disk we are studying? Because disk scheduling is the most important part of the operating system where the disk is to be managed. And why disk is to be managed? Because all the data which are stored permanently kept by the disk, that's why the disk scheduling is necessary. Now you can see here we have the 1 2 3 or approx 3 disk. So each and every disk is required to be understand through the some algorithm, because which disk or which plate is required to be accessed through the read write head, and that is also followed by the some algorithm, and those are the different algorithms. So we will see this concept one by one. So now it is clear to all what is mean by the magnetic disk structure. Yes, student, please tell me. Yes, student, please.
Yes, sir.
Okay, shall I move ahead?
Yes, sir.
Yes, sir.
So I'm just changing the my slide. So whatever I have discussed over here, so you can read out from here. A magnetic disk contains several platers or plates. Each plater is divided into the circular shaped track. Okay, so you can see into the previous slide as well. The length of the tracks nearby the center is less than the length of the track farther from the center. You can see into the diagram as well. And the track is further divided into its sector. It's shown into the previous diagram. Okay. So we have the plate. A plate is just contained by the disk, or on the disk or track, and we have the sector as well. So track of the same distance from the center from the cylinder, and the read write head is used to read the data from the sector of the magnetic disk. So this is a general overview idea about the magnetic disk structure. So I'm just sharing the notes over here. You can read out and go through these notes. Now, The speed of the disk is measured by the two parts, because when the performance is concerned, then it is necessary to understand what is the parameter by which we can measure the performance of the disk. So we have the two important factors, those are the transfer rate. The transfer rate determining that what is the transfer rate for data accessibility, it is writing or reading. Okay, so the definition part you can understand. The transfer rate means this is the rate at which the data moves from the disk to the computer. Please keep in mind the important word transfer rate. This is the rate at which the data moves from disk to the computer. So whenever we read the data from the disk to the computer, that is known as the transfer rate. So what is the transfer rate from data reading from the computer, reading from the disk to the computer. And next we have the random access time. So it is the sum of the seek time and the rotational latency. So now the question comes in our mind, so what is mean by the seek time and a rotational latency? So please keep in mind the transfer rate means the reading data read from the disk, and what is the speed or what is the rate of the data accessibility, that is known as the transfer rate. And when the random access time is concerned, so it determined that by the sum of the seek time and a rotational latency. So access time could be equal to the seek time plus a rotational latency. Latency is basically optional terms you can directly write down, note down in your mind, that is latency you can take. So the question comes in our mind, what is mean by the seek time? Seek time is the time taken by the arm to move to the required track. Please keep in mind, seek time is the time taken by the arm to the move to the required track. So when the what and the time which is required to arm to move to access the track, so this is known as seek time. Simple, you can say the accessibility of the track which is followed by the arm, so that is known as the seek time. And if when the rotational latency is concerned, so it can be defined as the time taken by the arm to reach the required sector in the track. So in the track, if your accessibility is some sector followed by the our arms, so that is known as the latency time, or it is also known as the rotational latency. Even though the disk is arranged as a sector or track physically, so data is logically arranged and addressed as an array of blocks of the fixed size. Please keep in mind, because each and every information it will store into the one array. Okay, so or we can say the an array form. It is just like the circular queue. So in the circular queue, it is look like the circular queue with the information to be stored. Okay, so the size of the block can be 512 or 1024 bytes. Each logical block is mapped with the sector on the disk and sequentially. In this way, each sector in the disk will have a logical address. So definitely in the computer science we are studying the logical address, physical address. So definitely when we need to access some information, so followed by the some address, and those are recognized by the logical address and physical address. So data is permanently stored in the physically, but it has some its own address whenever computer or when the CPU is required or demands some accessibility some data. So through the physical memory, data is easily accessibility through the its logical address. So same things we can have, and please keep in mind the data which is the disk or track or sector what we have, and that is also to be divided into the some fixed size blocks, and those are recognized by the whole HOLE, and this part we already discussed into the segmentation and paging concept. Okay, so that's why the disk is necessary part, because here disk determining that you are right now talking about the physically appearance of the view of the our mind what we have, because disk we can see sector sector or track we can't see, but we can see the its rotational not rotational, its arm, and we can see the some part which is visible to the user, but data we can't see, few things we not can't see. So that's why the track and sector is not easily visible, but we can read the sector, we can read the track. And somehow whenever we are reading the data and data is lost on the particular track or sector, what happened, a message will be given to the computer, and that is bad sector we have. Hard disk is damaged, some problem for access the data, so it means there are some bad sectors are available which are corrupt, which are not easily accessible, or which are having the some problems, or that's why we have the some bad sector. So this kind of the message we can access through the so many programs whenever we need to see hard disk is right now working properly or not. So there are lots of the tools are available into our market by which we can check the performance of the hard disk, how many sector we have, how many tracks we have, and how many desk sector we have. So this is the point we need to keep in mind. So there are lots of the tools are available by which we can see. So this is just idea about the our performance of the disk, and those can be recognized by the performance can be recognized by the transfer rate and random access time and seek time and latency. So these are the few terms by which we can measure the performance of the disk accessibility. Now I'm just coming to the disk scheduling algorithm. So before jumping to disk scheduling algorithm, so please let it be know what is the problem. Yes, please, anyone?
No problem, sir.
No problem, sir.
So shall I move ahead disk scheduling algorithm?
Yes, sir.
Okay, so
Yes,
in
sir.
this scheduling algorithm, it just look like the process scheduling algorithm, just like the process we need to schedule. So in the disk scheduling, we need to schedule the disk. So on the typically multi-programming system, there will be usually be multiple disk access requests at any point of the time. You can understand this point through an example. Suppose I am listening a beautiful song and I am watching, or I am just browsing the internet. Okay, so what happened? My particular web application is available on the my hard this primary memory through, because it is a browser installed on the my main disk part, that is a C drive we can say. But I am listening a beautiful song which is stored onto the my which is stored onto the where we can say which is stored onto the my D or E drives. But actually a browser is stored onto the C drive. So what happened at that time? What happened at that time? Because you are right now you are access the multiple drives at that time. Okay, so at that time what we need to manage, at that time the disk scheduling algorithm is required. So those requests must be scheduled to be good, achieve the good efficiency. So this scheduling is similar to the process scheduling. So I'm just coming to the my first scheduling algorithm, that is the FCFS. But before jumping over part, so I have just put it the few point over here, that is the most important part, and those are: operating system is responsible for using hardware efficiently for the disk drive. This means that having the fast access time and disk bandwidth. Disk bandwidth is determining that is the minimum speed and maximum speed. So what is the total time which is taken by the accessibility of the disk, that is recognized by the disk bandwidth. And next we have the minimize seek time. Seek time means, what do you mean by the seek time? As we know, the seek time means, we have discussed at this point, seek time is the time taken by the arm to move to the required tracks. So some information to be stored into the track, and when you are required to access some data, so ARM will take lots of time for access the data. Definitely you are having the bad concept, or you are having the bad accessibility. Suppose I am just want to click on a file and which is stored on the my particular drive, it takes around 5 minutes. So definitely the seek time is 5 minutes, and which is not good for the operating system, because you are not opening one file, two file, you are opening multiple files, or it takes a lots of time. So definitely seek time is just very high, so it is not a good thing. So this thing also to be managed by the operating system. Seek time must be minimized. Okay, so that's why I'm coming over here. So minimize seek time. Now seek time more is just equal to the seek distance. So into the various article or various books, the seek time is also recognized by the seek distance, and that is also equivalent to, we can say, disk bandwidth. You can understand by that is a total number of the byte transferred divided by the total time between the first request of the service and the completion of the last transfer. As I spoke you, that is the first time initial time and the last accessibility time. So you can measure by this time, but that is also recognized as simple term, that is we can have the total number of bytes transferred by divided by the total time between the first request. So time which is taken by the first request plus and time required which is taken by the last request. So first plus last request time divided by the total number of bytes to be transferred divided by the those part. So you can see the disk bandwidth. So this is a simple equation, simple formula, but most of the time calculation into the disk scheduling algorithm, we need to calculate the seek time, because seek time must be minimum. If seek time is minimum, so definitely the disk bandwidth will be the good by. So I'm just coming to the my next slide, that is the first come first services. This algorithm perform request in the same order asked by the system. So you can understand this part in easy way, as the first come first serve. So come first serve means is very simple, like the process scheduling algorithm, and for FCFS we have already discussed. Now, and first in first out, we have also discussed into the our important part, important concept into the previous class we have already discussed. That is, what was it? That is was the our what we have discussed into our previous class. What we have discussed into the previous class.
Sir, in previous class,
Okay, in the previous class we have discussed
before
FIFO. Yes, FIFO. FIFO is
LRU
what?
and LFO.
Yeah,
First in,
LRU.
first out.
So in which concept we have discussed this part?
Sir, page replacement.
Page replacement algorithm. Good. So in the page
Yes.
replacement algorithm, we have the first in first out. In the process scheduling, we have the FCFS. In the here in the disk scheduling algorithm, we have the FCFS. So same thing or same phenomenon, we can use the part or the concept or the term which is coming to the first, that is to be executed first in the process, of course. Same thing, we have the disk scheduling algorithm over here. So the algorithm perform the request in the same order asked by the system. So let's take an example where the queue has the following request: the cylinder number. Please keep in mind the cylinder number. Okay, so now what is cylinder? You can see, to go to the first this slide, that is the cylinder C. Okay, please keep in mind the cylinder C. Okay, so this cylinder C, it means 1 2 3. So here we have the 1 2 3 disk, and this is maintained by the cylinder. Okay, so I'm just coming to the my point. Yeah, so request by the cylinder number as follow. So cylinder number is just given to the each and every in the term. So 983, 37, 122, 14, 124, 65, and 67. This is an order way. This is a okay an order way. This is not a ascending or descending order in the sequential manner, or it is a order which is given by the cylinder number. So for the accessibility purpose. So assume that the head is initially at the 56. Okay, so I request to all the students, please use paper and pencil for solving this question. So please go to the open your page or register whatever you have, and see the example properly. Assume the head is initially at cylinder 56. The head moves in the given order in the queue is 56, 98, 183, and so on, so up to the 67. So which is the our initial point? Which is our initial point?
56.
Okay, so good. 56 is the initial point. So our first come first service is, which would be our next, that is a 98. Okay, and which would be the next after the 98? Definitely 183, and so on, so up to the we will go up to the 67 undoubtedly. Now let us understand this example through a diagrammatic way, so you can have this diagram. Okay, so we have total number of approx, we have the total number of the 200 cylinder. Okay, so we have the total number of 200. How to determine it? That is, it would be given. If it is not given, so we can assume, because what was the last value, that is 183. So you can assume that is a 200 or approx 200 cylinders given. So 0 to 199 in the sequential manner I can draw. So I am starting on my head was on the, this is head means arm head. So arm head was on the 56. Please keep in mind 56. Okay, so which is the next one? That is a 98. So I'm just coming to the 98. Okay, and after the 98, what was the next value? 183. What was the value? 183. So it is pointed over here. Okay, And then what was the next value? 37. Now 37. And thereafter we have the 124. Okay, 122, sorry. We have the 122 and then we have the 14. Then we will go to the 14. And then we have the 124. We have the 124. Then we will jump to the 124. And last we have the 65 and 67. So this is what this is the reading the this is what this is reading the now this is what this is reading the disk. Okay, and this is a disk on the basis of the cylinder. Now can anyone tell me what is mean by its total accessibility time? Can anyone just tell me? Can anyone tell me what is the its head movement time? Total head movement. Yes, this was the question. Okay. Now please tell me. Can anyone tell me its total head movement? Yes, student, please tell me.
Yes, sir.
Yes, tell me. I'm asking the total. I'm asking the total head movement. Okay, total head movement. Simple question I'm asking. Total head movement.
So 8.
8, sir.
Total head movements. Okay. No, it's no total 8 head movements. What happened?
9, sir.
No, you were on the first point, that was the 56. Okay, you were on the 56. You are coming from the 56 to 98. So 98 minus 56. Okay, then you are coming 183. So 183 minus 98. Okay, and then what was the next? 37. Okay, so then you are coming to the 98 to 56 and then 182 and then 37. So we can't take the negative value, so we need to pick only the positive value. So we can have the 183 minus 37, and then we can have the 122 minus 37, sorry, 37. Okay, and then 122 minus 14, and then 124 minus 14 and 65, and then 61, 65. Yes, please subtract each value and tell me.
So can you just move to that slide, so diagrammatic one?
Yes, please. You can. Total head movement. Okay, because what happened 56 to 98, what happened, head is moving, so total head movement will be the 98 minus 56.
So 37 minus 183 करेंगे कि 183 minus 37?
183 minus 37 करेंगे क्योंकि we will take the positive value. Movement कर रहे हैं ना, total movement, distance निकालेंगे. Okay, that is also distance. Okay. Oh, calculate. Actually, what I'm also doing the calculation over here. Okay. Yes. How much you are getting? Okay. For hint, I'm just can give you a help over here. Oh, where is okay? Oh, for mouse. Yes. This was slide. Yes. Now tell me. Total hand movement. Yes. Please tell me total hand movements.
Sir, 2 minutes.
Okay. Okay. No problem.
Sir, at last we have to add all the head movements now.
Yeah. Yes. 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 Yes.
Okay.
Initially, we have the 56.
Then,
Okay, please keep
then
it.
we will. It's simple, sir. Just directly final minus initials is 65 minus 56. 9 will be answer, sir.
No, 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 no. Total head movement incurred while serving this request. Okay, so we need to calculate the total head movements. You are
That
just
is
what happened? You are
98 minus
no,
56.
no. Okay, you are saying the cylinder. So you are jumping one cylinder to another cylinder. These are cylinder numbers. So these are the given the total nine cylinder. Okay, so the 9 cylinder, one cylinder just exists its time. So total head movement. Okay, so the head movement between the cylinder actually. So you need to calculate the head movement cylinder.
So 653.
653. Okay, just I'm just yeah. Now I'm just so 56. What is the value? 42.
Yes,
When
sir.
you're moving from 56 to 98, so you are just your head will move 42.
Yes, sir.
Okay. 98 minus 56, 42. Okay, and then 183 to sorry, yeah, sorry, 190, 98 to 183. So total will be the 85.
Yes, sir.
Please let it be know because I don't have solution right now over here, so I'm solving along with you. That's why I'm saying. So 42 we got it over here, and 85 we got it over here, and then we have the you are just from coming from the 183 to 37. So difference will be the or total will be the 146.
126.
Okay, good. And then 37 to the 122. So it would be 85.
Hmm.
Okay.
Yes, sir.
and then you are coming from 120 to the 14. So there will be the 108. Am I right?
Okay. Yes, sir.
Okay.
124
And
to 40.
and then 14
Sir,
to
110,
124.
sir.
No, you are coming from 122 to 14.
22.
And
Okay, sir. I thought
okay,
124.
then no,
Okay,
no.
okay, sir.
Then 14 to 124. So we have
Okay, sir. Okay, sir.
how much we have?
517 is
110.
110. Good. So that is the answer. We have the 110. Good. And now we have a 124 to 65. So it would be 59. Am I right? Please make the difference and just find the answer properly. 59. Yeah, subtract the value 124 minus 65. Because what happened? You are coming to
Yes, sir.
124 to 65. Okay, for accessibility the cylinder value, or we can see the access the disk as well. So now 59 we have and 2. Now do one thing. Sum 42, 85, 146, again 80, 85, and then 108, and then 110, 59, and then 2. Of course, last 2 we will get by the 65 to 67. So we will take the 2. So all these values you will get the 637. 637 is the total head movement incurred by the service requested by the all this disk. This is 137. Yes. Now did you got it? How we are getting the 1637? So into the examination, I may ask like this question: total head movement. So you need to find the total head movement followed by the first come first serve basis, and this value may be changed, and you have to sort out with proper way. What happened? 99% what will do mistake? Truly speaking, we will do the difference mistake. Whenever we need to get the minus value or between the two different values, what happened? We will do the 100%. We will do the mistakes. So please keep in mind the all these kind of calculation subtraction. Please keep in mind the subtraction part, and then add the properly. So it's a better idea to you can use a calculator for subtraction and calculation. Your answer will be the correct. Okay. So total head movement will be the 637 as I got. Did you all got the same? Yes, student, please tell me. So did you all got the same answer? 137. Okay, shall I move ahead? If it is clear to all.
Yes, sir.
Or any doubt, if you have any question over here, you can ask me, because rest of the things are depend on the same thing, but we have the different idea, nothing else. And we have the different algorithm. Those are recognized by the SSTF or shortest seek time Bala. And next we have the scan. So that's why I'm saying the first come first serve scheduling algorithm is clear to all. In this scheduling algorithm, what we need to find? We need to find the total head movement. Now it is clear to all. Then I'm just moving to my next slide. That is shortest seek time. That is also known as the SSTF. In the shortest seek time, what you need to do? You need to find the position is the closest to the current head position, and that is chosen the first, undoubtedly, without any problem. So I'm just making the sequence, and you can design or you can draw the scanning or the descheduling algorithm over the page in easy way. So what is the sequence you can find among the list of the all these values which is given by the program, or which is given by the system, followed by the shortest time? First we need to calculate. So our cylinder was on the first position, that is the 56. And among the 98, 183, 37, 122, 14, 124, 65 and 67, which is the closest value? Now, which is the closest value? Please tell me.
67.
67 or 65?
Oh, 65.
Right.
Okay, 65. Okay, so I will cross this value for understanding purpose. And then next, what is the next closest value to the 67? So it's 65, that is 67 undoubtedly. And what is the next closest value from the 67? 98, 130, 183, 37, 122, 14, 124. Which is the closest value? Just please tell me, because I don't know who is sleeping, who is just awakened over here. Please, this is the most important part for the your final examination. So definitely the 1 or 2 questions may ask into this part. Which is the closest value? Close value?
37.
Or 98? 37 close 97. Because if you're choosing the 37, the difference will be the 30. And if you're choosing the 98, so the difference will be the 31. So which is the closest value? 37?
Yes, sir.
37.
Yes, 37, because it is already written in here, that is 56, 56 is 65, and then next nearest is the 67, and then 37. So undoubtedly the answer is written into the our slide 37, and then 14, and then okay, 14 we have completed, 37 is completed, and then which is the closest value?
120.
128, 98, and then 98, and then 122, and then 124, and then 183. Okay, sorted seek time means you need to find the shortest or closest time which is close to the our given head times. So we have that is this diagram. So 56 we have over here, and the closest part, that is we have the 67. So simultaneously we need to find the total number of the head movement. So it is very easy to find out. So 56 65 minus 56, how much we are getting? 65 minus 56.
9.
Yes, good. So I'm writing over here. Okay, no problem. And then 65 to 67 I am coming. So 2. Then 67 to 37 we are coming. So we are getting the difference, that is a 30. Its distance is also known as the seek time or seek distance. Okay, so the which is equal to the seek time. So as we notify already into our previous example or previous slides as well. Now we got this value, and then 37 to the 14. So what is the difference between the 37 minus 14? So you will get it. What is the value? 20?
23.
23. Okay, and then 14 to 98. So how much value you are getting? It's 80, 84, and then 80, 188, which is the closest, that is a 122. So you can subtract 122 minus 98. So you are getting the value. Please tell me.
24.
Yeah, good. So 24 and then 2, and at the last what value we have? The 183 minus 124. So it is 59. If am I right?
Yes, sir.
And add all these values. You can use your mobile for calculation purpose only.
230.
230.
3.
So I didn't add over here, so I'm also adding. You can also add. So just let me add. So 9 plus 2 plus 33 plus 23 plus 84, then plus 24 plus 2 plus and last 59. Its value is 233. Okay, so the answer is 233. Now if I compare the sorted seek time algorithm, sorted seek time first algorithm with the first come first serve basis, so it is very easy to idea. If I'm choosing the FCFS algorithm, so total head movement require the 637. If I'm choosing SSTF, that is shortest seek time first algorithm for descheduling. So definitely the head movement will be the 233. The same number of cylinder if I need to access through the FCFS and SSTF. So according to the or comparison if I'm doing with these two algorithms, so definitely SSTF is the best algorithm for disk scheduling algorithm to manage the disk, and to manage the disk means to access the data from the its disk or to write the data as well. So SSTF is better than the FCFS. So now this is the idea about the SSTF and FCFS. So if there is a, and if you have any problem over here, then you can ask me. Else I can move to the my next algorithm. So now if we can compare, so definitely SSTP is much better. Now can I move to the my next algorithm, or if you have any doubt, then you can ask me. Student, please.
Yes, sir.
Yes, you have doubt, Anish.
No, sir. No doubt, sir.
So I'm just moving to the my next slide, that is the scan algorithm. Okay, so
Yes.
please keep in mind this important words and the simple algorithm we have. This algorithm is also called as the elevator algorithms because its behavior. Because as elevator, what is the elevator purpose? You can move into the one direction only, okay, and then go back.
Yes, sir.
Okay, so like the elevation, all the elevator as we know goes into the one direction only. Okay, no elevator can move into the both direction. So same things we can over here. It is also known as the elevator algorithms. So here the first head move into the one direction, that is we can say the backward. Okay, so and cover all the requests in the path, and then it moves to the opposite direction to cover the remaining requests. Please keep in mind, first is cover the all the one path or one path, and which is coming followed by the request, and then remaining or rest of the request will be covered by to the its back. Okay, it's back direction. It could be forward. So behavior is similar to an elevator as I speak you. So let's take in the previous example, the same example we have the all the cylinder numbers. Those are 98, 183, 37, 122, 14, 124, 65, and 67. Okay. So something is not a different thing. So I'm just coming to the diagrammatic way you can understand easy way scan algorithm. So in the scan algorithm, what I'm just going to the, I'm going to the back direction. Okay, I'm going to the this direction first. 56, and in the scan direction, please keep in mind in the scan direction you have to go into the first left direction, where truly speaking this is back direction and this is a backward. This is definitely it is a back direction as we know. Okay, and this is a forward direction undoubtedly. So what happened, into the left side or back side we need to go first, that is 56, and which is close which is the value we have the 37, and then we have the 47, sorry 14, and then we need to go its reverse part to cover the rest of the requests. Those are 65 and 67 and 98, 122 and 124, and then 183. It's a very simple concept. Okay, this is scan. Okay, scan, in the scan algorithm, first you need to scan the backward direction and then cover the forward direction for remaining. If remains are available, okay, if remains are available, then you can move to the forward. If remains are not available or some requests are not available, then you are not bothered about to move to the forward direction. Now same thing, you can find the difference over here, 56 minus 37 and so on. So please find all the positive direction, positive movements. You can't take the negative movements. If you try to do so, definitely the answer will be mismatch. So please keep in mind. So you can find your answer. This is the questions I'm just leaving for you. You can just find the total head movement. So total head movement. Okay. So if you have no problem over here, then I can move to the my next algorithm. Okay, anyone just having any problem over here? Sir, यहाँ पे doubt है. Please let us explain once more the scan algorithm, so I can explain. In the scan algorithm, what we need to do? We need to scan the backward direction first and then forward direction if requests are remain. In the first come first on the order basis we are getting the, we need to scan. In the shortest seek time, what we need to find the shortest or closest cylinder number and then scan, and so on. So process we need to go for the entire request scanning. And same thing in the scan purpose we have in the scan algorithm. What we need to do, we need to Scan all the cylinder numbers, all the disk values, we can say, followed by the forward direction manner, and then backward direction manner, and then forward direction manner. Now this part is clear to all? You all can do? Then shall I move ahead?
Yes, sir.
Okay, so there is no more confusion over here. So C scan. Since it provides a more uniform wait time than scan. So the head moves from one end to the disk is another, servicing the request. So okay, this is a theoretical point over here. In the C scan, you will not go to the what happened. You need to touch the its initial value, that could be 0. Okay, so just see this diagram, you can understand in easy way. In the what happened C scan, first you need to move to the forward direction. C stand for over here the circular actually. C stand for the circular, because what happened, C scan for the circular. Please keep in mind circular scan. It is also known as a circular scan. In the circular scan or C scan, we need to first move to the forward direction and then cover the all the forward direction base request, and touched is the last, that is the 199 as we assume, because or if it is not assumed then it will be given, that is a 200, total 200 head request is given. If this is not given, then we can assume by the maximum value. So what was the maximum value? That is 183. If it is not given, if it is given, then we can assume starting from 0 to 199 undoubtedly. Okay. So in the forward direction in the C scan, you need to move to the forward direction first, and then scan also the last value, that is the 199 we have assumed, and then go back to the backward direction to at the initial value, that is a 0. Okay, and then again start the process for the rest of the request, and those are the 14 and 37 over here. So now this is the C scan. Okay, and the head was started over here, that is a 53. In our previous example, head was started from the 56. Okay, so this is a different example we have over here. Head was started 53. So if you're looking for the difference between the 53 or 65, then difference will be the over here 12. Here we have the 2, and same thing here you will get the difference between the, that is the 32. Okay, and so you will get it. So definitely in the C scan, you may the different total number of the head movements. Now this C scan. Any doubt over here? Now through the example, theoretically you can read out when it reaches the other end, however it immediately return to the beginning of the disk without serving any request on the round trip. Same thing we have over here. So we need to find the total number of cylinders given. So if it is not given, then it must be given. If it is not given, then we can't solve this question. Okay, so here it is given, that is in the cylinders are into Q 98, 183, 37, 122, 14, and 124 and 65. Now there's no guarantee the cylinder will be started from the 56 or 53. I can take any value like 30. I'm just taking. Okay, 30 is my initial value where the cylinder will be started. Oh, sorry, head movement will be started. So I will I will choose this point. Okay, so that will be my beginning point. Beginning means I can from the pictorial representative I can take from here. So this is a point. So this is a C scan. I repeat my statement once again. What is mean by the scan? In the scan, first you need to go to the backward, and you will not touch the its initial that is 0 value and the last value, that is assumed, because which is not given to the and what was the last value for the maximum value we have, that is 183. So we will jump to the on the requested part into the backward, and then rest of the or remaining request to be measured by the its forward direction based. So in the scan, but in the scan you need to make a like a circular. Okay, so this is making like a circular. Okay, what happened? You are coming from this point to this point and this point to this point. So because this is our initial, this is our starting, and this is our last. Okay, so after covering the all the points, here circular somehow. So this is a C scan. Okay, any doubt over here in the scan and C scan? In the FCFS, SSTF, you have the scan, and now we have the C scan. Now, total number of 4 algorithms we have already discussed. Now, please tell me any doubt over here. You can ask me. Yes, students.
No, sir.
So, I'm asking questions to anyone. Okay, no problem. Okay, so I'm just one thing. Just let me ask a question. So roll number 19 BCY 10140. Who is?
Yes, sir.
Yes. Now, can you find the difference between the scan and the C scan? Shivam Agarwal. Shivam.
Yes, sir.
So what is the difference between a scan and C scan? Just tell me. Yes, please tell me the scan and C scan differences. Shivam, what happened?
Yes, sir. The only difference between S scan and C scan is that in C scan, it begins its scan towards the nearest and works it all the way to the end of the system.
Okay, good. And what about the scan?
Uh, uh,
Okay. So now what is the total head movement? Calculate it. Just total head movement. Just count, find the total head movement. Ayush Das. Ayush, could you tell me the head total movement? Ayush Das. Ayush. Ayush. Those students who are not speaking anything, I will not get the attendance. Okay. They will not be allowed to get the attendance. Yes. Oh, Ayush Das is having my problem. Okay, no problem. So Ayush Das, do one thing. Find the total head movement of the C-scan algorithm as you can see over the slide diagram and tell me and type into the chat box. And other thing I can ask to the other student as well. Next is Sanjay Kumar, roll number 19 BCY 10132. Okay, Sanjay. Now what is the total value of the total head movement of C-scan, this algorithm? Please tell me. Sanjay.
Yes,
I'm
sir.
noting down the.
So wait,
Yes, Sanjay.
wait for a minute, sir.
Yeah. I'm just waiting. No problem. And Ayush, you need to type on the chat box. Please keep in mind the head start at the 53, not the 56 peak. Okay. Yes, please tell me.
Sir, and
I
640.
640. And what about the Ayush? Did you type?
Sir,
Yes. Ayush? Okay, you are Sanjay or Ayush?
Sir Sanjay, sir.
Sanjay, what's the value? Your value is 640.
Sir.
Okay, now how did you get the 640? Please explain.
Sir, total disk number in given blocks are 98 and all this, sir.
Yeah, so 53 to 65 you are jumping, so
If the disk
12.
head is initially 53, first we have to move 53 to 98.
53 to 98. Why 53 to 98?
Sir,
In the
because
no, why you are moving from the 53 to 98? If you are moving from the 53 to 98, it means you are following the first come first services. Okay, in the C scan, I'm asking about C scan. Okay, the diagram is over here, and with the diagram, you need to find the total head movement. So what happened into the 53 to 65? We will jump. Why? Because in the C scan, first we will to the forward direction and then go to the initial point, that is the 0 we have, and then we will scan the rest of the request. So the difference between the first we have the 53 and then 65, so we have the 12, then 65 to 7 we have the 2, and then we have the 65 to 98, so we have the 32, and now we have the 24. I'm just writing directly. Okay, 59 and then 16, and you need to also count this 183 to 19 because you are touching this point, because this is also scannable part. So 183 to 199 we have to do. So 16 will come over here, and then 199 to 0 we are coming. So definitely total head movement will take around the 199 more time as well. And then again continue. So 0 to 14. So 14 will come over here, and here we need to divide. So definitely 23 will come over here. So please add all these value. Then you will get a C scan total head movement. Okay. So please keep in mind all these words.
381.
How much? I'm not adding. So please tell me correct answer.
381.
3
81.
81. 381.
Yes.
Okay, I don't have, that's why I'm saying on the basis of your beliefness, I'm just writing over here 1381. In the C scan, we have the 381. And FCFS, we found the 637. In the SSTF, we found the 223. So among all these three calculation, it is found that again, SSTF is much better than the C scan as well, C scan and FCFS as well. Okay, if you need to find the scan, so we can also find the same values over here without any problem. So you can find the total head movement. So C scan and C scan, this is a little bit difference we need to keep in mind. And next we have the look. Okay, so look is an basically a version of the scan, but there's a little bit difference you need to keep in mind, the scan and look. So please have a look on the look algorithm. So yeah, so look algorithm is an improved version of the scan algorithm. Please keep in mind it is an improved version of the scan algorithm, and head starts from the first request. Please keep in mind head request from the first request at the one end of the disk and move toward the last request. Please keep in mind. So look this example. Okay, this is example. This is a look. Okay, look will not go to the last. Okay, will not go to the last. It will go to the, or it will use the forward direction first and then go to the backward direction. It will not go to the initial point and last point. But in the scan we need to do. Okay, so that's why we can say it is improved version. Why we are moving from the 180 to 199, because it is 199 is it is not a cylinder number. It is not given to the our question, or it is not our countable part. So you are counting 16 and you are jumping again 199 to 0. So rather than the 199, it is better idea to go to the its scannable part, that is a 14, 41 or 14. So 199 we can reduce some part, so 16 will not count, and some part from 199 to 0 will be reduced. So definitely what happened, it saved number of it saves your total head movement, so it is better than the scan. Okay, it is better than the scan. So I'm just coming to the my point. So after reaching the last request at the other last request, not last endpoint, please keep in mind it is last request, and that was the 183, not last backend or last end. Okay, and had reversed its direction and then returned to the first request. Please keep in mind, then return to the first request at the starting and serving all the requests in between, and then same process we will repeat. Well, but in the case of the C-scan or scan, in the C-scan, sorry, we need to talk about the other end. Okay, this is the other end, and we discuss about the beginning part. But in the look part, we will not going through the this part. So this is the this is what we have the look. Now let us understand the difference between the scan and look algorithm. Scan algorithm scan all the cylinder of the disk starting from the one end to the other end, even if there are no requests at the end. But in the case of the look scan all the cylinder of the disk starting from the first request at end and last request on the other end. Okay, so in the scan we will need to go for the 0 and 99 we have to do also, but in the look 0 and 199 is not part of the cylinder number, so we will not cover this part. They're a little bit different. So this is the improved version. Okay, now this is a question I'm giving to the look example. So what are the sequence we have? The 98, 183, 41. Okay, 41 was the not previous example, or 41 was the not into previous example. So we have the included over here the 41, 122, 14, 124, 65, and last 67 we have. So initially it is represented by the 53, and the cylinder are numbered from the 0 to 99, or it can give the like value total number of cylinder like 200 is given. Okay, the question may change into the like that total number of cylinders are given 200. So total head movement in the number of cylinder incurred while servicing a request. So you need to find this question at a level. So now this is a solution. Okay, so this is a solution of the look. Okay, look algorithm. So this is an example of look algorithm. So we are not going to the this part 183 to 198 we are not going, and same thing we are not going to this part as well. So we are avoiding this part. So definitely it saves our total number of head movement in terms of the cylinder definitely. So we will save sometimes. So total head movement of the incurred while servicing can be requested, that is a 299. Okay, and if you're talking about the that one C-scan, so we got the 1381. So definitely 299 is of course is a lesser value than the 381. So C-scan or scan is much better than the its look or a head part. So same thing we have the C look. Into C look we need to go for that part. So C look, a version of the C scan. Yeah, here we have another example. Okay, in the C scan we need to go to the 183, and after the 183 we need to go to the its first request. Please keep in mind first request. Okay, this is a little bit difference. Okay, please keep in mind this is a little bit difference. In the look, what happened? In the look, you are going to the 183 and then you are going to the 41. Okay, 41 is much closer than the 14. Okay, but in the case of the C look, we have to the 183 and then we need to move to the first request, not the 41 or 37 what we have. Then we need to go to the its next process, that is the 37. So this is a little bit difference from the C look and look. Okay, so this is the difference you need to keep in mind. Yes, students, please keep in mind in the look we will not touch the first and last end. Okay, but in the C scan we will touch. Okay, but in the look we will not do. While in the CLOOK as well, in the CLOOK we will not touch first and last end, but we will jump to the first last request to the, or the upper last request we can say, or 183 to the, that is the other end first request, that is a 14. If same problem can be solved by the CSCAN, so what we need to do, we need to go to 183 to 199, and then we will jump to the, it's 0 and then 14 and then 37. It's a little bit difference we need to keep in mind, the CSCAN and CLOOK. Okay, is it clear to all? CSCAN, scan, and yes, student, please tell me. Yes, student. Hello. Yes, I use. Just let me see your answer. Your answer is 232. Okay, I will see. But I think answer was the 1381. Let it be. Okay, no problem.
So it was 382 coming. So mine was
It's 382 coming. Okay, I will see. Because what happened? One student told me the answer, that is 381. So I just noted down over that. Please, I didn't calculate. Okay. So if 382 you are all are getting the same value, so definitely it would be the correct answer, because one student or two student may wrong, but most of the student will not wrong. So 382 the would be the correct answer. Okay. Now come to the point.